Here's a problem involving the sum of items in an arithmetic sequence. Now, when we're adding the items in an arithmetic sequence, it's called an arithmetic series, and we actually have a formula to make the calculation. Let's develop the formula. Suppose I have the sum as I runs from 1 to 50 of this expression, items generated by this expression. We know that I has to take on the value 1 and 2 and 3 and 4 all the way up to 50. So we would be adding 50 items here. Now, certainly we could generate those separate items and add them, and if we wanted to take that kind of time, we could do that. But there is a way to develop a formula here, and I could just show it to you, or we can kind of step through it a little bit, and you might have a tendency to remember it a little more effectively, I believe. Now, because these items differ by the same amount from one another, there's kind of a stair-step effect. If we think about the steps of a stair as having value, that is, if we go up a rung of the stairs, then we're adding value, more value on this rung than the one previously, and so on. And we go all the way up these stairs from a sub 1 to a sub 50. It should make some sense that the middle item in the stairs would be the item which would be the average of all of these. And we can find that sum by taking the average size of one of these items, the average of all of these, times the number of items we have. So the average size of an item times the number of items would give us this entire sum. Now, usually to find an average, though, we add all the things that we have involved and we divide by the number of things we have. Well, it's the sum of the number of things that we're after here, so we're not going to use that technique to find the average. We can find the average, though, by doing this. We can take the first item and the last item, add them together, and divide by 2. You see, it's the average of the smallest one and largest one times n, because the average of the smallest and largest one is kind of like the one in the middle, which is the average for all of them. Now, when I say it's the value of the one in the middle, there isn't always a 1 in the middle. If there are an even number of items here, like 10, let's say, then there is no distinctly middle one. There are 5 that are up here and 5 that are down there, but no distinct middle one. If there are 11, however, then there are 5 at the top, 5 at the bottom, and that 6th item is the one in the middle, you see. So it would be the average size of an item. But here's the way we calculate the average size of the item. It's the first one and last one divided by 2. So it's a sub 1 plus a sub n. I'm doing this generally now. We'll apply it to this specific problem in just a moment. But the average of two things means add them and divide by 2, you see. And so that's the average size of an item. Now, a lot of times this expression is manipulated in different ways. It can be used like this, but we're going to use it kind of like this. We're going to write the n over 2 as a fraction and then times a sub 1 plus a sub n. And we're going to designate this as the sum of n items, S subscript n. The sum of n items from an arithmetic sequence is given by this formula. Let's use the formula on this particular problem. Now, we need a sub 1 and a sub n, so let's calculate that now. A sub 1, the first item in the sequence, would be, let's see, when I is 1, we have 3 times 1, 3, plus 4, that's 7. So a sub 1 is 7. A sub 50, the last item, you see, is, let's see, 3 times 50, 150, plus 4, 154. So 7 and 154. Let's come over here and use the formula. When we're asked to calculate the sum of n items, you see, we write the formula and then fill into the formula. We're adding 50 items here, so n is 50. A sub 1 we said was 7, a sub n 154. Adding here we get 161, 50 over 2 is 25. Multiplying we find the sum of those 50 items to be 4,025. In this one, we want to find the sum of the integers from 1 to 100. From 1 to 100, that means we're taking 1. We're adding 2, then 3, 4, and so on, all the way up to 100. All right, we can use our formula. Now, we know that we have, well, let's see, we have a built-in counting mechanism here. We have 100 items. So this is S sub n. Now, a lot of times when when we're subscripting here. Sometimes we leave it as S subscript n, or since we're adding 100 items here, we might make this 100 if we want to. That would be appropriate as well. We have 100 over 2 then times, let's see, the first item is 1, the last item is 100. So all of the information is kind of built in. We don't have anything to figure out. We just have to fill in and perform operations. So the sum of the first 100 integers, starting with 1, would be 50 times 101, which turns out to be 5,050. Here's one where we have a little bit of a calculation to make. Find the sum of the first 50 even positive integers. The first 50 even positive integers. Well, that would be, we start with 2. And then the next even positive integer would be 4. And the one after that, 6. And then 8, and so on. And we go all the way up, and the 50th one, gee, I don't know what's the 50th one is. What's the value of the 50th one? Well, I'm not sure. But we can figure that out because we have some way of generating the nth term of an arithmetic sequence, remember? So we can use that technique to find that 50th term. Here's what we know right at this moment, though. We know that we start with this idea of our formula, and then the information we know about this is that there are 50 items. So we have 50 over 2. The first item is 2, and it's the last item that we're not sure of at this point. So to find the value of that 50th item, we represent an expression for the nth term. And that expression is found by a sub n is the first term plus n minus 1 differences. Now, we know about the first term and the common difference of 2. So the a sub 1 is 2, the common difference is 2. Evaluating here, we find a sub n to be generated by the expression 2n. So the 50th term is 2 times 50, or 100. So we backtrack over here. A sub n is 100. And away we go. This is 25 times 102, which turns out to be 2,550 for the sum of these 50 items.